Hello everyone. In this section, I will talk about the basic concept of DMA operation. We will first talk about the general function of DMA operation. Then I will introduce the category of memory mapped distillation. Then I will introduce the scatter-gather function of DMA operation. Let's go. So what is DMA operation? The function is it can copy data from one system address to the other system address. And the first thing you may think about is we can use the CPU core to do the same function. Yes, you can just write a simple C code like this to implement the same function. It can copy data from source address to destination address. The data length is in this number. And usually, you can just call this function in the library. So, why we need to design a special hardware to implement this same function? Why? Okay, let's find the answer in later slides. This is an overview architecture of a SoC system. You can say this is the CPU core. This is the DMA controller we will design. And this is the memory mapped address the CPU and the DMA controller can access. There is also some memory mapped peripherals the CPU and the DMA block can access, such as the I2C, the UART, the timer, the GPIO block. So the CPU core can execute the memory copy function to move data from this location to this location, or move data from this location to this location. Also, it can move data from this location to this location. And in this project, we will design a DMA controller to implement the same function. That is, it can move data from here to there, from here to there, maybe also from here to there. So what's the benefit of implementing the same function in DMA controller? The first benefit is if the number of this variable is very big, for example, maybe 1024, or maybe even bigger. So if you use CPU to copy data, then this for loop will be executed for many rounds. Yes, this will take a lot of the CPU time. Then the CPU has low resource to do other functions. And if we use the DMA controller, the CPU may just configure several registers. Inside the DMA controller, the DMA controller will do the job of data movement. So this is the first benefit, lower the working load on CPU core. And the second is, if you use the for loop to copy data, it seems that there may just a single transfer. There may be just a single transfer at this point. If you have some understanding of bus system, the performance of the whole bus may increase if you use burst transfer. So if we implement the same function in DMA controller, we can choose a proper burst length at this point. The DMA controller can issue bus access with proper burst length that can improve the data bandwidth of the whole bus system. So this is the two benefits of implement the data movement in DMA controller. Okay, In this slide, we will categorize the memory mapped location to two different types. The first type is memory type, and the second type is periphery type. So what is memory type? That is, for this location, it's always ready to be read and written. For example, you can read and write this location at any time. For example, the SRAM, the DDR controller. And for periphery type, before each bit of read-write access, you may need to use other sidebound signals to check whether the destination is ready to be read or written. So let's take UART for example. The speed of UART is usually very low, maybe around several kHz. So the UART block will take several microseconds to receive a character from the UART interface, while the speed of our system bus is usually very faster, maybe at the speed of several hundred of megahertz. So for each cycle, there is just about several nanoseconds. So you can see when there is a charge received by UART, it will use an interrupt signal to tell CPU, I have received a character. You can read it from my memory mapped address now. And after this read operation, the CPU core can't read the UART again before the next interrupt. And for DMA controller, it also needs to handshake with the UART block first to make sure there is already a data available for read. For example, the DMA controller may assert the request signal high when it wants to read data from UART, and the UART block may assert the acknowledge signal high to acknowledge the request. So when both signals are high, the DMA controller may issue a read transfer on the bus to read a char from the UART block. And this is also true for the next characters. So if you want to receive 1000 characters from the UART interface, you have to handshake with the UART block for 1000 times. And if you use the CPU routing to read the same amount of data from UART, the CPU core may receive 1000 times of interrupt from UART. So you can see here, to receive 1000 characters from UART, if we use DMA controller, the CPU just configure several registers inside this block. Then the DMA controller will talk with UART and copy the 1000 data from UART to internal memory location. But if you use CPU core to do the same function, the CPU have to receive 1000 times of interrupt and jump to the interrupt routing for 1000 times. This is very inefficient for CPU core. Okay, let's summarize. So typically there will be 4 types of data transfer inside a SoC. From memory to memory, from memory to periphery, from periphery to memory, and from periphery to periphery. And for our project, we will implement this function. Okay, just from memory to memory. And in this slide, I will talk about the scatter and gather function in DMA operation. So what is scatter? That is, it will distribute data in consecutive address to different address locations. For example, this is the data at source location, and this is the data at destination location. At source location, data are stored in consecutive address, while at destination address, there is some gap between each segment of data. So if the DMA core can move data in such behavior, we say it supports the function of scatter. And in the reversed manner, it's a function of gather. That is, the DMA controller can gather data in different address to consecutive address. For example, this is the data at source location. This is the data at destination address. Copy data from here to there. We call it gather function. And in the reversed manner, copy data from here to there. We call it scatter function. I have explained the benefits of DMA before. Let's see next slide. So what's next? By now, you have some basic concept of DMA controller. What's the next steps to design our DMA block? First, you may read some design spec from other IP vendors, such as ARM, Synopsys, to find out the functions they support. If you think some features are wonderful and useful, yes, you can also implement these features in your DMA block. That is, we study from others. Then we will analyze the requirement of our application, define the features of our DMA block, and write it in a document. Then you have to figure out the data flow and control flow for our function block and the key points or the top points in this block, and figure out by using which hardware architecture we can deal with these difficult or tough points. Then you will divide the whole function to some subblocks. Then you need to go deep in each subblock and figure out the right hardware architecture for the tough parts inside each block. When these are done, you have to document your ideas. Then you can implement the subblock one by one and integrate all the subblocks up. Next, we have to analyze the test points and build the test case and environment and test environment for this block. Then we will do RTL simulation and debug to fully verify the function of our DMA block. Next, we will do lint check and design synthesis. And last, we will do FPGA emulation. We will put the IP in a FPGA project and run it up. First, we may do self-test. That is, we just test the function of DMA block. After this, we may put it in a real application, such as the Plants vs. Zombies 2D game. If lucky we passed all the steps, we can release the IP. At this time, we will cheers and take a vacation. Okay. In this course, I will need you to go through all these steps. And I think you will learn a lot from this complex and useful IP design project. If you are interested in, please follow me to finish this tough project. Thanks.